IES Technology Electronic Training Center. The PNP Bipolar Junction Transistor. Overview. What is a PNP transistor? Current-controlled bipolar device. The bipolar junction PNP transistor is a three-terminal, three-layer current-controlled device that can function as either an amplifier or as an electronic switch. The PNP transistor is the exact opposite of the NPN transistor. Its construction consists of two interconnected diodes which are reversed with respect to the NPN transistor, producing a positive-negative-positive type of configuration. The arrow which defines the emitter terminal points inwards in the PNP symbol, the opposite of the NPN. All polarities for a PNP transistor are reversed, meaning it sinks current into its base, whereas the NPN sources current through its base. The main difference between the two types, holes are the more important carriers for PNP transistors, whereas electrons are the important carriers for NPN transistors. PNP transistor construction and configuration. The construction of a PNP transistor consists of two P-type semiconductor materials on either side of an N-type material. PNP transistors use a small base current and a negative base voltage to control a much larger emitter-collector current. Physical construction. Two P-type semiconductor layers sandwich a central N-type layer, forming the emitter, base, and collector terminals respectively. Note: the arrow within the PNP symbol defines the emitter terminal with conventional current flowing into the transistor. Voltage relationships. In other words, for a PNP transistor, the emitter is more positive with respect to the base. The emitter is more positive with respect to the collector. The base terminal is always biased negative with respect to the emitter. The PNP transistor has very similar characteristics to NPN bipolar transistors, except that the polarities, or biasing, of the current and voltage directions are always reversed, applicable across all three configurations: common base, common emitter, and common collector. Biasing, current flow and key equations. Base emitter. VBE bias condition. The voltage between base and emitter, VBE, is negative at the base and positive at the emitter. To cause base current to flow, the base must be more negative than the emitter by approximately 0.7 V for a silicon device, 0.3 V for a germanium device. Circuit connections. Supply connections. The emitter is connected to the supply voltage VCC. The load resistor RL limits maximum current and is connected to the collector terminal. The base voltage VB is biased negative with respect to the emitter and is connected to the base resistor RB, which limits maximum base current. The emitter supply voltage is positive with respect to the collector, VCE. Equations. Base and collector current equations. The same formulas used for NPN transistors apply to PNP transistors. The key relationship is IC equals IEIB. IC equals B.IBIB equals IC divided B. So for the PNP circuit, IC equals IEIB, because current must leave the base. PNP transistor as a switch. The PNP transistor can replace NPN transistors in most electronic circuits. The only difference is the polarities of the voltages and the directions of current flow. Below is an example of a simple PNP transistor switching circuit. A simple PNP transistor switch. The output characteristics curves for a PNP transistor look very similar to those for an equivalent NPN transistor, except that they are rotated by 180 degrees to account for the reverse polarity voltages and currents. Electron current flows out of the base and collector towards the battery. PNP switch operating conditions. A PNP transistor is defined as being normally OFF. To turn it on, a small output current must flow. A negative voltage must be applied at the base, B, relative to the emitter, E. This allows a much larger emitter-collector current to flow. PNP transistors conduct when VE is much greater than VC. Key rule: a bipolar PNP transistor will only conduct if both the base and collector terminals are negative with respect to the emitter. Bipolar transistor switches are used in many applications to switch a DC current on or off. From LEDs requiring only a few milliamps of low DC voltages, to motors, lamps, and relays which may require higher voltages or currents. Complementary bipolar transistors. You may wonder, what is the point of having a PNP transistor when NPN transistors are widely available? Having both types is a great advantage in many circuit designs. Class B amplifiers use complementary NPN and PNP transistors in their power output stage. The NPN conducts for the positive half of the signal, the PNP conducts for the negative half, driving current through the load in both directions. Bidirectional motor control. Complementary pairs enable bidirectional motor control, switching regulators, and CMOS, complementary metal oxide semiconductor, logic circuits applications that demand symmetrical performance. Matched pairs. Complementary transistors are pairs of matched NPN/PNP devices with nearly identical electrical characteristics. Examples: 2N3904, NPN/2N3906, PNP, and TIP 3055, NPN/TIP 2955, PNP. DC current gain, beta. Complementary transistors have a DC current gain, beta, IC/IB. Matched to within 10% and a high collector current of about 15 amp, making them ideal for general motor control or robotic applications. Class B output stage. In a Class B amplifier, the output current is shared evenly between the two complementary transistors, allowing the amplifier to drive the required power through a load, loudspeaker, in both directions at the stated nominal impedance, and power output current is likely to be in the order of several amps. How to identify NPN or PNP? Transistors are essentially two diodes connected back to back. We can use this analogy to determine whether a transistor is PNP or NPN by testing resistance between the three leads, emitter, base, and collector, using a multimeter. Testing each pair in both directions results in 6 tests total. The expected resistance values for each terminal pairing are shown below for both PNP and NPN transistors. Between transistor terminals: PNP/NPN. Collector emitter. PNP resistor high. NPN resistor high. Collector base. PNP resistor low. NPN resistor high. Emitter collector. PNP resistor high. NPN resistor high. Emitter base. PNP resistor low. NPN resistor high. Base collector. PNP resistor high. NPN resistor low. Base emitter. PNP resistor high. NPN resistor low. Summary: key PNP transistor concepts. Here is a concise recap of the most important principles governing PNP transistor operation and design. 1. Opposite of NPN. PNP is a current-controlled bipolar device with reversed polarities. Holes are the dominant carriers. The emitter arrow points inward in the circuit symbol. 2. Biasing rules. The emitter is always more positive than both base and collector. Base must be negative with respect to emitter by 0.7 voltage, C, or 0.3 voltage, GU. To enable conduction. 3. Normally off. A PNP transistor is OFF by default. Both the base and collector must be negative with respect to the emitter to switch it on and allow emitter-collector current to flow. 4. Complementary use. Paired with NPN transistors, PNP devices enable Class B amplifiers, bidirectional motor control, CMOS logic, and other symmetrical circuit designs requiring matched complementary pairs. Next topic. In the next tutorial, we will look at the operation of the transistor in its saturation and cutoff regions, examining how a transistor acts as a switch in practical DC switching applications. Bipolar transistor switches are used in many applications, from LEDs requiring only a few milliamps at low DC voltages, to motors, lamps, and relays requiring higher voltages or currents to operate correctly. Contact us for services. IES Technology Limited. Telephone 711-71041, 50255686. Email info@iestechnology.com.qa. Web www.iestechnology.com.qa.